Hello, my name is Shawn Krueger. Welcome to Claris Engage. This session is called JSON, You Deserve a Raise. Before we get into the technical details, a quick introduction. Who am I? As I said, my name is Shawn. I work for LuminFire in Minneapolis, Minnesota. You can find me on Claris Community as Fly By Night. I'm also active on Twitter, MattGeek27, and now my FileMaker backstory. Like so many, I kind of came into FileMaker a little sideways. I worked in the printing industry for 22 years. Along the way, I had a boss that had an old Casio programmable keyboard. It was a big horizontal thing about yay big. It had a program on it called Press Pricer, and basically it would walk you through, enter in the quantity, your cost for ink, your cost for paper, yada yada yada, and in the end it would spit out a number. I recreated that in FileMaker 6, and our numbers matched, so we got the approval. We started doing all of our quotes in FileMaker. We can actually print out a nice looking quote to give to the customer. And eventually along the way, the program grew. It ran our whole business. It became job tracking and everything along the way, job tickets, all of that. And I learned more and more, mostly self-taught. I did have a mentor that I would take out to lunch every now and then and pick his brain. Also a lot from TechNet, which is now the Claris community. And then those owners retired, sold the business, and I went to work for a different company that was around 6 times larger, but they were still handwriting their job tickets. So I said, hey guys, can I fix that for you? I built a new system. This time I think it was FileMaker 12, and having learned a lot more, implemented a lot more best practices along the way, and now their system is running on FileMaker as well. But now that that was up and running, there was still a to-do list here and there, but it was mostly up and going and working well. So my main job was back to prepress, and I decided that was kind of boring. I didn't like that as much as I liked developing in FileMaker. So then I really dove in. Went through the FileMaker training series, paid my own way to DevCon 2014 in San Antonio. My wife and I took a road trip down there. While I was in sessions, she would go do some sightseeing, and we had a great time. Met some wonderful people, made some great connections. When I got back, I started doing some freelance work, and pretty soon after that, had a job offer with LuminFire, and I've been there for a little over 6 years now. It's fantastic working in so many different industries now. We've got manufacturing, nonprofits, you name it. Get to learn a lot of different businesses and meet a lot of people. I also worked for Apple before that, and it was a lot harder leaving Apple than it was leaving the print industry, but I gotta say the hours are so much better than retail, and having one job instead of 2 is a little easier on the family life. My other hobbies include musical theater, where I met my wonderful wife. We now have 2 daughters, and it's a real pleasure being able to sing and act on stage with them, as well as work with my wife, likes doing stage management, keeping us all on task there. Over the last couple years, I've also taken up smoking. Meat, that is. My favorite is brisket, but I also enjoy ribs, pork butt, turkey, salmon, lamb, you name it. Don't get me started. I've got way too many smokers if you ask my wife, but I really enjoy my big offset that she's nicknamed the Beast. But enough about me. Let's dive into some JSON. Enjoy. I want you to leave these sessions feeling empowered and wanting to use JSON for everything. We like to say around the office that there is no technology problem that cannot be solved with JSON. Well, okay, maybe not any problem, but we like to use it a lot. And hopefully you'll see why. So here we go. Part 1. What is JSON and why should I, a FileMaker developer, care? Some resources that you'll want to check out. JSON.org is where you'll find all the specs for the standard. There's a blog post at LuminFire that I wrote that much of this session will be based on. And of course, a lot of the big FileMaker consultant shops, Geist Interactive, Soliant, etc., have probably written about it as well, and you can find some great information there. And don't forget the FileMaker help documentation. So, what is JSON? It's an acronym that is short for JavaScript Object Notation. You don't need to know that. It's a big text string that has a structure to it. It's a data interchange format, kind of like XML, but a lot easier to read. It's a way to pass data from one place to another in a way that is structured, predictable, and universal across multiple programming languages and platforms. And best of all, it can be formatted in a way that's easy to parse, not only by computers, but also by humans. JSON has become the de facto standard for passing data to and getting data out of most web services or APIs. You can pass JSON data to an API, and you will likely receive JSON as a response. Increasingly, FileMaker is not an island. Web services are plentiful, inexpensive, and the industry standard. You don't need to reinvent the wheel in FileMaker if it doesn't make sense. Use the best tools for the job and connect them all with FileMaker and or Claris Connect. So I'm sure we're familiar with scripts in FileMaker. We can pass scripts a parameter, but we can only pass a single parameter. Often we want to pass more than one piece of data to our scripts. The limit on parameters is generous, just shy of 1 million characters, so we can pass a lot of data, but we need to be able to parse that out on the other side. There are multiple ways of doing that. We can pass a list of items. So in the first example there, you'll see just 3 items there separated by a pilcrow or carriage return. And when we get that back, we'll just have those items in a list, and we can use the get value to parse them out. If we want to make it a little more readable, we can add some comments with the 2 slashes so we can say what the parameter is for. And it's a pretty acceptable way of getting things around. But there are a few gotchas. For one, things need to be in a predictable order. You can't swap things around and have your script just know what's going to be coming in that spot. And you can't skip things. If there's a blank, you have to include a blank in that spot. Another thing is, if one or more values will contain returns or be a list of values or IDs itself, then we need another way to delimitate the values from each other. Rather than relying on a parameter or value being located at a particular place in the list of values that we're passing, what if instead we could call each item by name? This is a common convention known as name-value pairs. There are many conventions for doing this, all with various caveats and difficulties to implement. Custom functions are now easier to distribute than they have ever been before, since everyone has the, quote, advanced version of FileMaker, even though it's no longer in the title. But it's still not as portable as just native functions. Well, ever since version 16, we were given native functions to create and parse JSON. So why don't we just use that? So in this one, we're going to start diving into FileMaker's JSON functions. Some things to know. In JSON, there are keys and values, or name-value pairs. The data inside a value is encoded. You'll see the diagram on the right showing some of the ways that that data is escaped or encoded. But again, you don't need to worry about that. FileMaker's JSON functions handle all of this for you. Now, the order of keys doesn't matter. In fact, FileMaker is going to reorder it anyway, so don't sweat it. Whatever order you pass it in, whatever you get back will be reordered alphabetically. Arrays, on the other hand, have a specific order and a numbered spot. We'll find out later that that number starts with 0, and that's important to keep in mind. Another thing to remember is that JSON keys or paths are case sensitive. This is kind of a different thing for a lot of FileMaker developers because FileMaker lets us get away with a lot that is not case sensitive. FileMaker variables, we can even specify field names, and FileMaker will just take care of that for us. But when we're dealing with JSON, we have to keep things case sensitive. Another thing to remember is that JSON values have a data type. There are strings, which it can be any piece of text, and those are always quoted with double quotes. Numbers are not quoted. You would just say 27. You wouldn't have the 27 in quotes. A JSON object will be surrounded by curly braces. This means that you can have one JSON object inside the value of another JSON object. You can nest things. Things will have a hierarchy. This is important to know and can be a powerful feature. Arrays, which again, as we said earlier, have a specific order to them, will be denoted by square brackets as opposed to the curly braces. The next data type is a Boolean. This is true or false. Much like FileMaker has Boolean functions, those exist here too. Another thing that's a little different for FileMaker developers is the concept of null. Now typically we would just pass an empty string like quote quote with nothing in between them, but null means absolutely nothing, and it will say null without quotes around it. More on these data types later. JSON format elements is a handy function to keep around. Its only purpose is to make things nicer for us to read. That's us humans. It makes no difference to FileMaker or any API that you may be passing data to. Extra white space in your JSON is ignored by the computer, but can be really handy for us to read. In this example on the left, we see just kind of a big run-on string of data that's hard to interpret. But if we surround that with JSON format elements, we can pretty easily see that we have an address, we have several fields within address, and then we have other name value pairs after that, like company, first name, ID, last name, etc. JSON list keys, like it sounds, returns a list of keys. Here, taking our previous example, the expression on the left will return all of the top level keys in our JSON data. You'll notice that it just has address, but we had other fields within that, or other name value pairs within that. It only returns that level that we specify. So the second parameter that we pass into that is the key or path that we want to look at. So here, if we pass address on the right, then we'll see all of the keys within that point on the path. JSON list values, as you might guess, returns the values instead of the keys. It's kind of the counterpart to that one. So here we can see if we just pass a blank parameter for the second one, so we only want the top level things, we'll get our values back, but you'll notice that the first one isn't just a plain value, it's a whole JSON object. That's because our address contained a JSON object full of names and values. The inset on the right, we will specifically call out that address, and then we'll see just the values within there. So here you can see that a value can be just a plain text string, or another JSON object, or it could be an array. There are lots of ways that we can put data together. JSON getElement is going to be the tool that we will use most often to extract a specific value from a JSON object. Now here we see a couple examples. The one on the left and down a little is the simpler one. Out of our field, that is JSON data, we're just looking for the value that corresponds with the key of first name. So if I tell it first name, I'm going to get back Tim. But what if we have more complicated data to work with? In this case, we're going to send along a path to hone in on the specific piece of data we want. In this example, I'm looking at the address array, and I'm specifying array number 2, which is actually going to be the third spot since arrays always start with 0. And then within that, I'm looking for the value in city. In this case, I get back Bloomington. Note that in our path, the array number is going to be inside a bracket, and then anything nested is going to be separated with a period or a dot. We refer to this as dot notation, and you'll see it a lot moving forward. Now we're going to dive into creating and editing. The two functions that we'll be looking at are JSONDeleteElement and JSONSetElement. First, JSONDeleteElement. As the name suggests, it's going to remove an item from our JSON. Here on the left, we see a field with JSON data. On the right, we're telling JSONDeleteElement to target that field with JSON data, and then we're specifying a key that we want to delete, in this case, first name. You'll see in the results that first name of Tim, the name and the value are both gone. This is an important thing to remember. This isn't just clearing a value, it's actually deleting that whole name-value pair from our JSON. And if we delete an item like address that contains an object or possibly an array, it's going to delete everything at that point in the path. In this case, address contains multiple sub-name value pairs that are all inside a JSON object. If we tell JSONDeleteElement to delete address, it's going to delete everything. But let's say we've got an array, and we just want to delete one of them. So we'll see on the right we have an array with 4 items or 4 addresses, and we want to delete address number 2. Remember, arrays always start with 0, so address number 2 is actually the third address in our array. You can see in the result, by deleting address number 2, that West Market in Bloomington is gone. Address number 3 in the 4th spot moves up to take its place. Now, JSONSetElement. This is the main function that you will use to set JSON, meaning create a new JSON object or modify an existing JSON object. It has 4 parameters. The first parameter is JSON. If we want to create new JSON, we will type curly braces inside quotes, saying that we're going to start a new JSON object. We could also use square brackets if we were starting a new array. If you are modifying or adding to existing JSON, you can call out the field or the variable where the JSON is currently stored. The next parameter is key or index or path. Wow, that's a mouthful. Most often, this will simply be the key or the name in your name value pair that you're setting or adding to your JSON. If you have a nested hierarchy of keys, that becomes known as a path. And we specify that using the dot notation that you saw earlier. So if we have objects in a hierarchy, we could have level 1 dot level 2 dot level 3. Another option is an index, and if we're specifying a specific item to set or add to our JSON, that index will be a number in a bracket. So we could have address bracket 2 dot street. This will set or return the street key within the third item in the address array. Our next parameter is value. You guessed it. This is the value in your name-value pair. This is typically the piece or one of many pieces of data that we're trying to get from one place to another. In value, we can specify a string of quoted text, we can enter in a number, or we can put in a field name or a variable or an entire calculation. We can put anything we want into that one parameter. The final parameter is type. Remember from earlier, the data types for JSON? Well, it relates to that, but it doesn't specifically follow that. We actually have some specific things, and we're going to dive into that in the next section. So some things to know. There are 7 JSON data types that are supported in this last parameter. Each one has a name and a number value, much like how some other FileMaker reserved words evaluate to a number. It's a bit of trivia to know them, but you really don't need to learn them. Unless you're at the bar at Claris Engage and there's trivia going on and you could win something, other than that, don't bother. You can use the number, but you sacrifice a lot of readability and it really doesn't gain you anything. So here we go. Now, the first one is JSON raw. This is the same as passing an empty string in this spot. It evaluates to 0. With this one, FileMaker will take a guess at what kind of data the data type should be. Let's just say that when working with FileMaker data, FileMaker makes some questionable assumptions, so you'd be better off making this determination yourself. In this example, we're passing in an address, 123 Main Street, and we're telling it the data type is JSON raw. Well, FileMaker sees the 123 in there and says, hey, this is a number, and it drops the rest of the string. Probably not what you want, but you notice I put a little asterisk there. We have found one circumstance where JSON raw can be valuable to use. If you're receiving data back from some web APIs and you aren't sure exactly what you'll get back, JSON raw can correctly detect a JSON object or array. And this can be valuable because a JSON string would add extra encoding versus JSON raw, it will keep the JSON object or array intact. And so it can just become part of your nested JSON structure. But when dealing with FileMaker data, just never use this one, okay? JSON string. This is the one that we'll be using most often. So in this example, we're passing in an address, more than just a single address field. We're passing in an address that has a street address, a return, city, state, and zip or postal code. Notice that that return got changed to a \r. Remember way back in our example from JSON.org, we mentioned that JSON data in the value gets encoded. And there are some special characters that get escaped. And here's the example where FileMaker just takes care of it for you. I can't stress enough, don't try to figure this out. Just let it do its thing. It will encode it on the way in, it will decode it on the way out, and you don't have to worry about it. The next data type is JSON number, which evaluates to number 2. This one acts very similar to wrapping your value in the getAsNumber function. In this example where we're passing a street address, a city, state, and zip or postal code, just like getAsNumber, it's going to take all of the numbers, drop any of the text, and just cram those numbers together. In this case, probably not what we want, but this is an extreme example. Another important thing to remember is that JSON number can never be blank. If you pass a blank string, it's going to end up as 0. Now, if you want to preserve the difference between 0 and blank, you might want to just pass it as JSON string. One other limitation, this one comes from the JavaScript world. JSON number does not handle extremely long numbers well. Once you get over 18 digits, what you get back is returned in scientific notation. It drops off any of that extra detail. So if you're comparing really large numbers and those numbers are important, you're not going to want to use this. If you're passing a big string of numbers, like for instance some UUID values, you're going to want to use JSON string instead of JSON number. Next we have JSON object, number 3. Previously we saw that we can have nested JSON data, that is, a value that is another JSON object. In this case, address, and we're nesting in there address 1, address 2, city, state, etc. It's a way to help us organize things. Now, if we have something that we know is already a JSON object, we're going to want to use this data type. If we just pass it as string, it's going to re-encode that data. Now, it's not a big deal. We can get that element back out, and it will take that extra encoding or escaping back out of there, but it gets a lot harder to read. Especially if you pass multiple things this way, you can have a bunch of extra slashes in there that just don't do you any good. In a similar way, we can specify an item as JSON array. In this example, we're passing in multiple addresses and we're specifying that as an array. Again, if we just specify it as string, we get a bunch of extra encoding or escaping characters that just make it less readable. JSON Boolean. Just like in FileMaker, we've got the getAsBoolean function. This will act very similar to that. The results will be a lowercase true or false. Now, in FileMaker, the reserved true and false words are uppercase without any quotes. But in the JSON result, we'll get the lowercase. So here we've got some examples and some gotchas. You'll see uppercase T, R-U-E, the FileMaker true, returns true, as does a 1. We often use a 1 or a 0 to specify true or false. But note that if we pass in true in quotes, that evaluates to false. This would do the same thing if you wrapped it in getAsBoolean. And then we see a 0 or false with a capital F and no quotes evaluates to false. We probably don't want to pass in something that we don't expect to be a Boolean, because then we'll just get unexpected results. In this case, we're passing in a street address, and because there's a number in there, that's going to evaluate to true. So you have to be careful about this one and use it the way you're expecting it to be used. The last data type is JSON null. Now, remember in JavaScript and JSON, null is a concept that we don't really have in FileMaker. The closest thing we have is an empty string. But with null, it specifically says null instead of just an empty set of quotes. If you use JSON null as the data type, no matter what you pass in, null will be the result. It doesn't matter if it's true or false or a string of data, it's all going to be converted to null. I haven't found a real-world use for this one. Maybe someone can show me. Welcome to Part 5 of JSON You Deserve Arrays. Now that we've covered the data types, let's dive into creating and editing some JSON. JSONSetElement is going to be our main tool for this. In this part, we're going to be diving in and doing some demoing directly in FileMaker. So this might be a little looser than the previous parts. What? It gets even looser? Oh boy. Stick with me, folks. This is going to be fun. Okay, here we are in FileMaker Pro. I'm using the contacts sample database. Anyone can open this up by going to File, Create New, Contact Starter Solution. In this case, I've already populated it with some sample data, showing my friend Tim here, and a few addresses associated with his company. Let's bring up the data viewer, and we'll start working with JSONSetElement. Quick pro tip, you can type the acronym for many things in the script debugger or the data viewer, any place you've got the calc engine. So for JSONSetElement, we can just type JSE, and now we've got our function ready to go. Hit return, and it drops us right in. We're going to take the parameters one at a time here. Now we're going to start a new JSON object by typing our curly braces. I'm going to call the key for this hello with a value of world, and our type is JSON string. There you go. You just made some JSON. Hello world. Now let's start integrating our FileMaker data. We're going to name our key whatever makes sense. In this case, let's go with address. And then for the data, instead of having a coded string, we're going to specify one of our fields. In this case, this is coming from the addresses table, and we'll just say address line 1. So here you go. We've got our name value pair, address, and one infinite loop. But just a single key value pair isn't that impressive. As with most things, there are multiple ways to get more data in your JSON. I'm going to bring up the script workspace. Here we're going to start a new script. Now we're going to set a variable. I'm going to call that variable myJSON. Now when we start out, we'll put the same thing we had before. I'm going to put an exit script step just so that we can run it through debugger, see what's happening before it leaves. So let's try that out. We'll save, open up our debugger, complete that step, and we'll see in the current tab here we have our variable myJSON with our name value pair of address and one infinite loop. Now we can add to that. I'm going to duplicate that script step. We're going to update the myJSON variable. In this case, since we're not creating new JSON, we're going to replace this with our variable. We're going to add city to that. And now let's see what happens when we run that. First step, same as we had before. Now the next step, instead of replacing that, we've added to it. We've added another name value pair. Here you can see it's all in one string, but if we want to, we can add a watch item. JFE will give us JSON format elements. And there, now we've got that formatted, easy to read. Let's go ahead and leave that in the data viewer. Note that we can also change an item instead of adding to it. Let's duplicate that again. And this time, instead of referencing a field, I'm just going to say, type in a string of Minneapolis. We'll go back to our current tab, save our script, and run the debugger again. Once again, the first step fires, we have our address. The second step fires, we've got our city added of Cupertino, but now when this step fires, we've replaced the value of Cupertino with Minneapolis. That's because we told this value to go to the key of city. That key was already there, so we're going to overwrite it. The last action always wins when you're setting JSON. But rather than setting things in multiple steps, we can actually do that all in one. Let me show you. Create a new JSON object again. This time, we're going to set multiple sets of key value pairs in one calling of JSONSetElement. This works much like the substitute command, where we can have several pairs, or in this case, triads, because we've got 3 parameters here, that get repeated surrounded by brackets. There we go. The only difference between this right now and what we had earlier is this set of brackets surrounding these 3 parameters. But we can copy that and we can add another one separated by a semicolon. And now we can put our city in here. And there we go, all in one call of the JSONSetElement, we can do multiple items. Very powerful stuff. Okay, here I've added a lot more fields, and now you can see my JSON is getting a little difficult to read. So let's wrap that in JSON format elements. And there you go. Simple to read name value pairs. But let's give this a little organization. Remember, we can nest JSON objects inside of each other to group like keys. In this case, let's put everything related to an address together into one object. Here, I'm specifying address using our dot notation and then putting my address1 name value pair inside that. All I have to do is do that to all my others. And now you see all of my address fields are neatly tucked inside this one name or key. Note that if you have nested keys, the JSON object is the value for the higher level key. In this example, we can't also set a value to the key of address. If there are conflicts, the last one wins. I'll demonstrate here. Now you'll see, even though I had all of this to create my nested address object, because I set this one after, at that address path, that one won. Again, the last setting of any point in your key paths will win. This is also true if we are setting our JSON in multiple sets in a script. We're back in our contact starter solution. As you can see, I have a portal here with multiple addresses. If we take a look at our relationship diagram, you'll see we've got a relationship set up from contacts to addresses, a simple primary key to foreign key relationship. This allows us to show multiple records in the address table on one contact record. But, as we saw, whenever we specify one of the address fields in the address table, we only get the first related record, one infinite loop, but we have other records there. This would make a great array. Let's use a script to loop through or walk the portal, building an array of our addresses. Let's go into layout mode and make sure that this portal object has a name. Here I've given it the name of portal.addresses. You can use whatever naming convention you like. Now, let's make a script to walk through that and build our array. Before we start, let's figure out how many addresses we should have. We're going to set a variable and call it address count. We'll use the count function on a field that will always have a value, in this case, the primary key of the addresses table. A quick pro tip. Another option is to create a field with an unstored calculation of getFoundCount in every table. Then you can just reference that field. On larger data sets, this will be more performant than the count function. But for now, we'll just go ahead with this. Let's create a variable for our iterator or counter. We'll just call that I, and we'll set it to a starting value of 0. You could set it to 1, but since JSON arrays are 0-based, we'll have cases where we need to add or subtract 1 to get it to even out with either our spot in the array or the completion of our address count. I'm going to go with 0 because it's just one place to correct instead of every place that we want to set this. Now let's add a loop. Before we go into the loop, we're going to go to Object, and we're going to specify the object name of our portal.addresses. Inside the loop, we're going to go to a portal row. We're going to specify that by calculation. In this case, we're going to use our iterator or counter. But remember, we're starting with 0, so here's a spot where we're going to add 1 because there's no portal row of 0. To make sure our loop doesn't end up an infinite loop, we're going to make sure that we increase our iterator. Call that I plus 1. And we'll need an exit condition. We will exit if I is equal to our address count. We've already increased our counter by 1, so we don't need to correct for the 0-based indexing here. Now let's go back up and set our JSON. So that we have something to start with, we're going to set our JSON above. And I'm pasting in the JSON that we were using in our previous example, but I'm going to take out all the address fields. Now inside of our loop, I'm going to add each individual address to the array. Once again, we're going to use JSONSetElement, and we're going to update the myJSON variable. I'm going to paste in my address fields to get me started. To include an array item, we have to have a number within brackets. The first one would be 0, but let's use our counter to increment that number as we go. We'll copy and paste that on down. And then we'll get rid of this trailing semicolon. Let's add an exit script step and then test it out. We still have the JSON format elements myJSON variable in our data viewer. But right now nothing is set, so we have this error message. As soon as we step into our script, now it is set, and if we hover over it, we'll see there's our 3 name value pairs for company, first name, and last name. Moving on with our script, we'll get our address count, start our iterator, go to the portal, go to the first row. Now we'll update our JSON with the address array. Let's take a moment and look at that. There we go. There's our first address. You'll see it's inside brackets, and then inside that bracket is our JSON object with our address fields. Or increment our counter, check to see if we should exit, which we won't yet. We'll do the loop again. We'll go to the next portal row, and now we'll update our JSON again. Let's take a look. Now we have two addresses. The array is contained by the square brackets, and we have two objects inside separated by a comma. Once again, FileMaker's JSON functions take care of all of this formatting for us. We'll step through the rest of the script until we get out of our loop, and now let's take one more look. Here we go. We have our four addresses in our array. We've just made an array in our JSON object. Congratulations! But, as always, there's more than one way to skin that proverbial cat. We can get to the same result with calculations, if you don't mind having a couple calculated fields in your schema. Let's take a look at Manage Database and our fields. I've taken the liberty of setting up a JSON data field, but this one just targeted the related fields directly, so it's only going to get that first related record. Not exactly what we want. Let's go over to the addresses table. Here I created a JSON data calculation with just the name value pairs for the address fields. This would represent everything inside of that address object, each individual JSON object in the array, one for each record. In this version, I'm going to reference our calculated JSON object from addresses for our address array. In this case, I'm going to use one of the JSON Edition's custom functions from Geist Interactive. The link to download them will be in the presentation. What we're doing here is saying JSON array from related and then referencing our JSON data field in the addresses table. What this is going to do is concatenate those related fields together into a JSON array. We'll use the JSON array type to make sure it's formatted correctly. Let's duplicate this item and take a look at our JSON data to field. Here you'll see it looks exactly like what we got in our script. We have an array with four addresses enclosed in the square braces, each address its own JSON object inside the curly braces. There you go, two distinct methods for creating JSON arrays. We've already looked at how to create JSON, modify JSON, and inspect JSON. Now let's look at some practical examples of using it in your solution. For this one, I'm borrowing a script from LuminFire's FMignite Essentials, a free starter solution that you can download. Let's dig in. For this example, I'm going to be demonstrating one of my favorite scripts called setFields. This script is completely modular, and to demonstrate that, I've simply copied and pasted it from FMignite Essentials into the contact starter solution that we've been working with. The purpose of this script, as the name implies, is to set fields. Often we want to set values into a field using a button or another script. Sometimes we want to set one field, sometimes we want to set multiple fields, and occasionally there are things that we want to do along with that. Maybe we want to commit the record, maybe we've got a pop-over open that we want to close, or a window that we want to close. Rather than have several specific scripts to handle all of these cases, we have this one script that can do all of that for us, and we call it repeatedly. So let's take a look. One of the first things you'll see is this example parameter. We do this so that if you're attaching the script to a button or calling it from another script, all you have to do is go in here, copy these example parameters, and then paste that into your button parameter or perform script parameter. Then you just enter in your specific data to do what you want. The main part where we're setting fields happens right up at the top. We're going to set an array of field names and field values. Later we'll use that with the set field by name script step and put in the value that we want. All we have to do is pass in our field name here, which is wrapped in getFieldName, and then enter whatever string, number, or calculation that we want that value to be in here. If we want additional fields, we just increase our array count from 0 to 1, add those steps, and then keep adding. There's no limit to the number of fields you can set with this script. If you're not using this one, we would just delete that from our specific parameters. The rest of the parameters are a series of booleans to control additional actions that we can do. Like we mentioned, if we're committing, we'll set doCommit to 1. If we have a popover that we want to close, we'll set doClosePopover. We also have parameters for refresh and flushing options, including specific objects or portals that you can pass in a name. After you've set your fields, you may want to go to a specific portal, row, or object name. That can all be handled here. Okay, now let's put it to use. We're back in the Contact Starter solution. This time I've added a couple fields. I have a status field, and I've got a VIP checkbox. Let's make that a little nicer looking. I'm using this as a Boolean field, so I created a value list that I've just called Boolean1. The only value is the number 1. But we don't need that number 1 to show, so we'll just make that field a little smaller. We'll move our label a little closer. And rather than using that checkbox, we're going to surround the whole thing with a button. We're going to attach a script to our button, and you guessed it, that script is setFields. Here we're just going to go into our script briefly, grab our sample parameters, copy that, and paste it here. Now what we want to happen is we're going to set our VIP checkbox. We're going to toggle that, so we're going to tell it not is VIP. Now the other field we're going to set is our status field. And here we're just going to set a text value of important. We're going to go ahead and commit that. We don't have a popover or a worker window that we want to close. We don't need to do any window or object refreshing. But in this case, let's go to another object. If this person's important, I think I want to call them. So let's go to tab.phone. Now I'm going to name this tab panel tab.phone. Let's open up the script debugger and watch what happens when we click this button. You'll see we're going to call our setField script. We first check to make sure that we have valid JSON. Next, we're going to set parameters to local script variables. This is optional, but I think it makes the script a lot more readable, and you can follow along in the data viewer in the current tab and watch your parameters get filled out. This makes it easy to see what's happening in your script. Now we have two fields that we're going to set. We're going to do a loop through here, set our first field name, There, we set that checkbox to 1. We've got one more field to set though. We're going to set our status to important. Now we're going to exit the loop. No popover to close. Here we're going to do our commit. Check for an error, move on. No worker window to close. We didn't do any refreshing, so we'll skip past these. We're not going to a portal, but we are going to go to an object. Here we go. Here's our go to object name. There we go. Now we're on our phone tab. And we're done with our script. So there you go. One script that set 2 fields, committed our record, and went to another object ready for the user to take further action. Feel free to download FMignite Essentials, tinker around with it, and maybe use this script in your own solution. When you're designing your own scripts, you can format it any way that you want. You can arrange things and nest things in whatever way makes logical sense to you. But, as we said earlier, FileMaker is not an island. Many times we want to reach out and interact with web APIs. When we're doing that, we don't get to choose how to format our JSON data. They're going to tell us how they expect it, and we have to make our data match that. Let's dive in and take a look. Here we're looking at the web page for the WooCommerce REST API documentation. WooCommerce is a very common e-commerce plugin for WordPress. This session is not going to teach you how to integrate your FileMaker app with WooCommerce. That's a much bigger discussion. But part of that is going to be formatting your data into a JSON object that WooCommerce will accept. And that is something that's applicable here. In this documentation, we're going to find products because we're interested in creating a product. Here we'll find a list of product properties, attributes that can be called fields, type is the data type that goes in there, and then a description. Notice that some things are read-only, some things are going to be optional, some are going to be required. Right now we're interested in creating a product and what we need there. Here we'll see the HTTP endpoint that we're going to hit. We would be using something like FileMaker's insert from URL script step, or you could be using a helper tool like Claris Connect or FMFlare or one of the many other third-party tools out there. Note that over on the right we have some code examples for different programming languages. In this case we're using curl. In the example they provide, the top has some curl headers. We're not going to cover how to create those here. But notice this last one, this D, that stands for data. This is our product data. Notice that this is all enclosed in curly braces. Hey, guess what? That's a JSON object. Inside of that, we'll see some name-value pairs. This one is name, premium quality. This one is regular price, $21.99. We'll also notice that there are some arrays in here. This is an array with 2 items. This is an array with 2 items as well. Let's take a look at a FileMaker database and see if we can get our data to match. Here I have the FileMaker inventory starter solution. Again, you can find this by going to File, Create New, and look under Starter Solutions for Inventory. I did add a field or 2 here, but the basics are there. We've got a part number, we've got a manufacturer, a description, a product name, and over here we've got a price. I'm going to move this over to the right so that we can see it, but let's start creating some JSON. I'm going to open up the data viewer. Let's start off right away with JSE, JSONSetElement. We're creating a new JSON object, so we've got our braces. And I know that we're going to have several items here, so I'm going to go ahead and indent this It's just how I like to format it to keep things readable. Now we're going to start with the first name-value pair here. The key is name. So I'm going to go ahead and type that. But wait a minute. Note that I like to put things in uppercase or Pascal case or camel case for readability. But remember, JSON keys are case sensitive. This API is expecting name in all lowercase. Therefore, I need to match mine to that. There we go. Now I'm going to grab my product name field, and the type of this is going to be JSON string. There we go. There we've got our first name value pair for this item. Let's add another one. The next one is type. Now this one, I just happen to know that WooCommerce has particular product types. There are simple products and there are variable products and some others, but for the sake of simplicity here, we'll go with simple. Next, we've got regular price, and that's regular underscore price. Again, matching exactly. One thing to note here is this price, even though a price is generally a number, you'll see that it's quoted. Therefore, it's expecting it as a string. So we'll leave this as JSON string. I also notice that I'm starting to get a big string of JSON data here. Let's make it a little easier to read. Remember how to do that? That's right. JFE, JSON Format Elements. We'll just wrap the whole thing in that, and there we go. Simple name value pairs that we can read. Now we'll add another one. Description. I have a description field, so that works. They have one called short description. I don't have a field named that in my solution, but just in case it's a required field, I'm going to go ahead and send the same thing. Can't hurt, right? Next, we have categories. Now, this would be something that we would need to get from WooCommerce. We would need to know the category IDs. So in this case, you'd probably get it from like a related table in your FileMaker database, but those items would have synced with WooCommerce earlier so that we know the ID. In this case, we're just going to fake our way through it and match what they have here. So we've got an array, so I'm going to type categories and then put in a 0 in brackets, so this will be my first item in that array. And then within that, I'll add a dot notation there for ID, and we'll put 9. One thing to note, this 9 is in quotes, but the one over here is not. That tells me it's expecting it as a number, not a string. So let's change the data type to JSON number. Let's add another one of these. We're going to increment this one item in our array, so this will be 1. Remember, arrays always start with 0. The next one will be 14. Next, we have images, which is also an array. And notice this is not an image like you would have in a FileMaker container field. We can't send container data this way unless we encode it with something like base64 encoding. But that's obviously not what's here in our example. What it's expecting is a URL for the product image that is stored online somewhere. And I do have a field in my file for an image URL. So I'll put that there. So now let's compare. Other than the name value pairs not being in the same order, which, remember, that doesn't matter. FileMaker is always going to reorder things in alphabetical order. Everything else looks pretty much the same. We've got our categories with an array. We have images with an array. This one only happens to have one item, but that's okay. Typically, when something is expecting an array, you can have one item or several. It doesn't matter. So once we would have this incorporated into our insert from URL scripts tab, we would get a response. That response would look like this down here. When we get that, we'll want to set that into a variable, and then we can pull out any of that data that we get back that we want to store. For example, the ID. That's the ID that is stored on WooCommerce. So we don't know that until we submit it. So we would put that JSON response in a variable, and then we would say JSON get element, our response, and then ID, lowercase here, would be the key that we want to retrieve, and the result of that would be 794. Once you know how to parse and create JSON, this stuff becomes simple. I hope you feel empowered. Okay, we've covered everything that we set out to cover in JSON You Deserve a Raise. But there is one more thing. With the latest version of FileMaker, FileMaker gave us a new script step. So new, in fact, that it didn't even make the documentation. It's called Execute FileMaker Data API. Welcome to Bonus Part 9. For some resources on this, check out the Geist Interactive blog post linked here, and if you're into geeky backstory, check out the Context podcast from May 26, 2020 to hear about how this script step came to be. In a nutshell, they were looking for a way to return JSON data, similar to what we get with the execute SQL function. Well, it turns out there's already a way built in, the FileMaker Data API. Now, don't get confused, this has nothing to do with FileMaker Server. The Data API is actually built into the entire platform. This script step exposes it for us in FileMaker Pro, FileMaker Go, and even WebDirect. A more accurate name might have been Get FileMaker Data as JSON or something like that, but since they're using the Data API, this is what they called it. And it's a really interesting thing. Let's take a look. Here we are back in the Contact Starter solution. Let's open up the script workspace, and I've got a script ready to go here with the Execute FileMaker Data API script step. We specify a target. This can be either a field or a variable. In this case, we'll store it in a variable called JSON.DAPI. If you've used the Data API before, you know that it references a FileMaker layout and can do some things like limit the number of returns, and you can also offset them. That way, you can batch process a large number of records a little bit at a time. So, in a simple context, all we need to supply is the layout, a limit, and an offset. And let's see what we get. Let's pop open the data viewer. And here we see our JSON.DAPI variable. There's a lot of stuff in there. Let's make that a little more readable with our friend JSON format elements. There's a lot of data to unpack, so let's take a look. First, a message. We've got a code of 0, message is OK. That tells us that it worked. If something was wrong, we'd have an error code there instead. Next, we've got our response, and this also has multiple sections. We've got data. Inside there, we have field data. We have our modification ID. We've got portal data. And here you see we have multiple portals. We've got email addresses, phone numbers, and addresses. This is starting to look very similar to what we had before when we built an array of addresses. The only difference is that each key is the fully qualified field name. We also get some metadata. Portal data info. We have our database name. We found 2 records in the return table of phone numbers. We found 1 record in email addresses, and we found 4 records in addresses. Interesting stuff. Now we've got our field data in our main one. There are 2 records, so this is the other one. You can see that these were returned as an array. The first one is this record that we're looking at. And then here's where it splits to the next one, and we get all the data about that record. And then here's our data info about the base table for contacts. Our layout is contact details. We return 2 records. We get all of this data back, and we didn't have to write any JSON using JSONSetElements. Pretty handy. Let's take a look at what else we can do. Some of the other commands that we can send include query and sort. Now, for a simple query, we can just say query the primary key and fill in that data with the primary key of this record. That's going to return this record and only this record. So in our previous example, we returned 2 records, which are both of them that are in this database. Now if I save it and run this, note that I only have 1 record returned. So here we can see our found count is 1. Our total record count is still 2. We returned 1. We still get all of the related records, so we get the 4 addresses that are related to this parent record. We get the 2 phone numbers, the 1 email address, and all of that metadata as well. Start to think about the power that this script step gives you. I can't wait to see what all of the FileMaker community of developers does with this new tool.